Welcome to the Dialog Forum Chemical Recycling. We will have this forum in 2 languages, German and English, and we will have simultaneous interpreting. First of all, thank you very much for your interest. We were really surprised about how many people were interested. We had more than 100 people registering, so thank you very much for your interest. We were able to convince many experts to participate. Thank you very much to them. And we have a full agenda. And I have to be very strict when it comes to your time slots. We have a lot of guests and time is scarce today, but we will not be in a hurry, of course. Ladies and gentlemen, the opportunities and limits of chemical recycling, well, this was something that we've heard about a lot, and this was the motivation for the dialogue. We want to discuss chemical recycling and sustainability, and of course there are justified questions, especially when it comes to effects on the environment, aspects regarding the environment. We'd like to focus on this. So the first goal today is, content-wise, we will focus on technology and environment. And let me be very clear, what we cannot discuss is standards, regulatory aspects, or political aspects regarding chemical recycling, but we will focus on technology and the environment. And of course, we cannot discuss costs, prices, and volumes for competitive reasons. And as it is semi-public, this is not possible, and please bear this in mind during the forum. Ladies and gentlemen, chemical recycling is cooperation, and it requires a lot of different players and activities. Collecting waste, sorting it, converting it into oils, and producing products for sophisticated applications at the end of the day. So the second goal was to include a lot of different participants and to hear about a lot of different aspects from the value chain. The agenda is quite dense. Let's take a brief look at it. Mr. Kissau will give a brief introduction. I will then introduce the individual speakers, one after the other. And after a first long section where it's about the importance of chemical recycling for packaging manufacturers, pyrolysis, where waste turns into a raw material, then the results of LCA regarding chemical recycling, an assessment by our critical reviews, then we will take a break. After the break, there will be a first round of discussion, and please send us your questions via the chat. Then we have a second section and a second discussion round at the end of this meeting. After every speaker, you have a chance to ask brief questions if you didn't comprehend something properly, but please be very brief because there will be a discussion after the break and another one later. And we have a chat where you can send us your questions in English and German. We will try to answer the questions in the respective language. And please bear with me. Looking at the agenda and the number of participants, I don't think we'll have the opportunity to answer all the questions here today. So one thing is for sure, we will record this forum, and the many questions we hope you will ask, we will include them in our Q&A catalog on the web. And wherever necessary or possible, of course, bilateral discussion after the forum is possible, and we will give you a web page and an address where to turn to. So thus far, my first information. Now let me introduce our first speaker, Dr. Lars Kissau. Lars is working in petrochemicals. He's the head of strategic global business development of petrochemicals. So he's in charge on our activities regarding chemical recycling. I think he can give us a good introduction into chemical recycling. I'm very glad to be here today, and I'm very, very glad that we have so many participants virtually here today. Chemical recycling is a very important topic for BASF. As Thorsten just said, it's very important for myself. It's part of my job. And also in my private life, it's important. A brief story. I have a 16-year-old daughter, And at the age of 16, she's not very much interested in Dad's work. Some weeks ago, I discussed a work she had to do for school regarding plastic waste with her and what we do at BASF, ChemCycling. And she said, "That's cool, Dad." And it made clear that this is an important topic for the next generation as well. So I'm glad that we can have a critical discussion about this topic here today to get it going. And life cycle assessment is also important here today, which BASF did together with partners and that we'd like to discuss with you. And before we hear from experts, I'd like to explain to you why BASF is dealing with ChemCycling and how we started the project and what we've achieved so far. Now let's first of all take a look at how we deal in the European Union with plastic waste. You see that about 1/3 of waste becomes part of the cycle via mechanical recycling and then is available. The majority of this waste, 2/3, are not made available again, but end up on landfills or are energetically recovered, which means incinerated and thus causing CO2 emissions. Chemical recycling only contributes a very, very small part to this overall market. And we hope that chemical recycling can complement mechanical recycling to make sure that all of the recycled raw material flows is increased and we have more material staying in this cycle. Now, let's take a look at the plastic value chains as we see them today and how they might look in future, maybe differently. In the chemical industry, we have crude oil. We receive naphtha from the refinery. This is split up in the steam crackers, and these feedstocks then turn into polymers, plastics. And the plastics, after one type of utilization, turn into waste and are incinerated at the end of the life or end up on a landfill. 1/3 in the European Union is recycled mechanically already. This works very well for some types of plastics, but there are some limits. It's limited to clean flows of waste because mixtures cannot be processed. Pure polyethylene, for example, here you can have a splitting and you can reprocess it. So you need clean flows of waste and you have to separate it properly. And there is a disadvantage because of the mechanical processing and the end quality of the recycled product are not 100% identical with the virgin grade material. There are some requirements regarding hygiene and quality, and impurities are in the way here because you do not have a virgin type material. Chemical recycling works differently using a process called pyrolysis. Here, plastic waste streams, these can have impurities. They are split up into their molecular elements. And in the existing chemical plants, such as steam crackers, they can be processed. And at the beginning, they are then reintroduced into the value cycle. The advantage being that with this processing, you clean the material. So non-pure plastics can also be processed, and in a mass balance approach, you can have end products which quality-wise are not different from the virgin grade products, only the carbon looks a little different here. Between chemical recycling and mechanical recycling, we have another opportunity for specific polymers, depolymerization, that is chemical splitting up a polymer into its individual polymers. This works for specific polymers, and the end product are up to the original quality because we can purify the raw material. But this processing is limited to specific polymers, and we are convinced that all these methods complement each other, and they should be assessed in an LCA to make sure that we understand which method is good for what type of material. It doesn't make sense for a mechanically recycled stream to use a different method if we then have a disadvantageous footprint at the end. So the LCAs, as we did them for ChemCycling, help us in identifying the correct method. I mentioned that I briefly would like to explain how we approach the ChemCycling method. Some things change in the value chain. For example, you have to work with several partners and you want to work with several partners. One company cannot do this on its own. It's several partners working together. The ChemCycling project works as follows. We take the waste of consumers, plastic waste, mixed waste, used tires. All this is collected and separated. And our partners who are in charge of the pyrolysis then process this. The end product here is a pyrolysis oil, which then can be used here in the steam cracker, for example, instead of naphtha. The raw material is processed in a mass balance approach. It becomes part of new products, and the C-cycled products can be acquired by our customers because they just are different due to their raw material base. This method offers a lot of advantages. It complements existing recycling methods, and we can contribute to increasing the general recycling quotas. It is regenerative, so especially when it comes to high-performance plastics or multi-layer packaging, we try to make it part of a recycling method, which is not possible today. So we contribute to a circular economy and use another raw material stream for the chemical industry. Instead of crude oil, we use used plastics. So we replace other fossil resources, and this way we reduce our CO2 footprint, which is important to BASF. And we have a top quality of the end products, which are no different from the virgin quality products. And this way, via this approach, we make it possible for customers to reach their own aims in terms of, for example, recycling quotas. What have we achieved so far? The project was started a while ago, and we have one commercial application, a multi-layer packaging for mozzarella cheese, for example, transparent plastics in refrigerators and other appliances. Here, plastics on the basis of ChemCycling are used already. So as BASF, we enhanced our network of partners, and with Quantafuel, Pyrum, and New Energy, our new partners, we can further develop this methodology, and so pyrolysis oil can be used. We work with our partners on a technological basis in order to further develop the method and use it more and more. The mass balance approach is very important, and we already have an external certification here to make sure that our customers can be sure that this is correctly certified. And regarding life cycle assessment, what we want to discuss here today, we received an independent assessment proving that ChemCycling is not only good when it comes to reducing waste streams and is good for the circular economy, but also improves the CO2 footprint compared to other processing of plastic waste. So we keep developing it. We look forward to the discussion. And with this, I'd like to pass the floor back to Thorsten. Thank you, Lars. Very, very well done, because you did not overstay your welcome here. So there are no urgent questions so far. Great.